This is our second video based on the chapter Chemical Reactions and Equations. This is the continuity of the first page, that is with the previous page number 1 accountancy textbook. We had discussed about burning of magnesium ribbon forming the product magnesium oxide. Now we are in the second chemical reaction, that is with potassium iodide, the compound that we are going to see now, potassium iodide. Whenever we are going to learn about these potassium iodides, we must remember about the crisscross method, how they were formed. Potassium valency is +1. It's a monovalent cation. Iodide is an monovalent anion. It's +1 and 1. They both were crisscrossed with each other to give potassium iodide. That is from grade 9 standard topic. Now the reactant named we call as potassium iodide. Then it is going to react with lead nitrate. Now let us see the name lead and nitrate. Lead is one of the elements in this one, Pb. Its valency is 2+, whereas nitrate, once we see, it is a polyvalent ion. In the 9th standard we have learned monovalent ions and polyvalent ions. So the lead being dipositive ion, its valency is 2, whereas nitrate and O3 together its valency is 1. So once we crisscross them, we get the formula PbNO3 twice. This is the easiest way, children, to study the chemical formulas of any compounds from your grade 9th standard. So first you read the fundamentals of the grade 9th standard, then knowing to by heart the formulas, you can understand how they will be originated. Now our activity 1.2 in the chapter number 1, the second activity is going to study the chemical reaction between potassium iodide and lead nitrate. These are salts. A salt is a neutral substance that is generally soluble in water. There are many kinds of salts. In this kind, the potassium iodide is a water soluble salt. Hence, it is being colorless. It is a water soluble salt. We have taken one test tube. In the test tube, we had filled some water. Into that water, we had added some amount of potassium iodide. It was completely soluble in that water. And we are choosing another test tube. And in that another test tube, we have taken some water and we are going to add little potassium nitrate into them. This potassium nitrate is also a water soluble salt. And now in these test tubes, in the test tube A, according to my version, there is an salt solution of potassium iodide. Salt solution of potassium iodide. In the test tube B, there is the salt solution of lead nitrate. Now these are our reactants. These are our reactants. Previously we learned that a chemical reaction involves in converting the reactants into new compounds, that is products. So how these reactants are going to combine with each other? Means when we mix with each other, when we add the potassium iodide to lead nitrate, we can find two types of levels here. One of the compound that will be settling at the bottom of the test tube. The compound that settles at the bottom of the test tube is appearing in yellow color. and we call it as the yellow precipitate. We call it as the yellow precipitate. Whenever the word comes, the word precipitate, it is the water insoluble substance. Water insoluble substance. And here, when potassium iodide is combined with lead nitrate, they are going to exchange their atoms between each other. The two molecules or compounds, they are going to exchange their atoms. Also, potassium is going to get nitrate in place of iodine. So, the potassium now got nitrate in the place of iodine, and it is forming the potassium nitrate. It forms at the top. This colorless solution is the potassium nitrate because it is completely water soluble. Whereas previously on the reactant side, lead used to be combined with nitrate, but on the product side, the lead had accepted iodide, potassium had accepted nitrate. So lead is forming lead iodide. Lead is forming the lead iodide, PbI2. Now we can have it out how to balance the lead iodide. Previously we came to know lead shows 2 plus divalent positive ion. Iodide shows minus ion. Hence we get Pb2 plus iodide minus. So this 2 and 1, once we crisscross, we get PbI2. So the formula of lead iodide is PbI2. Here in this reaction, what we can know is at the end of a chemical reaction, that when the products are formed, we are able to observe that there is a change in color. So in this chemical reaction, what we had observed is when potassium iodide reacts with lead nitrate, it is forming lead iodide, the yellow precipitate, and potassium nitrate. In this session, we are going to continue about the next observation that we are going to observe during a chemical reaction. Up to now, we have observed 2 observations in the chemical reaction. That is, when a magnesium ribbon is burned, it is forming powdered magnesium oxide. That is, there is a change in the state. And when lead iodide is reacted with lead nitrate, it is forming the potassium iodide. When reacting with lead nitrate, it is forming lead iodide and yellow color precipitate. There is a change in color. Now we are going to observe an activity 1.3. Before we continue with this activity, we will be having some questions. Have we observed the curd is stored in any container, metallic container? Generally, the curd we do not preserve in any metallic container for long duration. But in general, we store it in a hot pot. That's we call matka. That is made up of pot, mud, and we may store in a plastic container. What is the reason behind this? Why the curd is not stored in any metallic container, but why is it stored in a non-metallic container? Because the curd, when long standing, it forms the acidic in nature. Generally, the acids reacts with the metals to release some hydrogen gas, and that hydrogen gas, when enters into the curd, it changes its taste and spoils the food. So we will not preserve the curd in any metallic containers that are going to react with the curd. Instead, we store the curd in a pot that is made up of clay, that we call matka, or we store the curd in a plastic container. So in this explanation we came to know acids will react with metallic substances. So for this, in the grade 10 standard we were given with another activity. The activity, once we have a glance, we had taken one conical flask. Our laboratory equipment. Into this, we had added some dilute hydrochloric acid or dilute sulfuric acid. Observe children, we will take only one, either hydrochloric acid or either diluted sulfuric acid. Just 20 ml, it is very less amount. For that, we are going to place, before we place the cork, we are going to place small pieces of zinc. These small pieces of zinc, they are called as the zinc granules. These zinc granules are the metallic state. So previously what we have learned is acids reacts with metals like our curd and the container. Now similarly we got the hydrochloric acid diluted state and our metal is with the zinc. We want to observe what is the possibility here. Here the metal will displace hydrogen from the acid in the form of hydrogen gas. Metals will displace the hydrogen from acids in the form of the hydrogen gas, and in return they will combine with the remaining atoms of the reactants. Please observe I didn't balance the reaction. According to the 9th standard topic, the zinc shows a 2 plus valence C, whereas the chloride shows minus 1 valence. 2 and 1 crisscrossing, we have Z and Cl2. Means 2 of the chlorine atoms will combine with 1 of the zinc. Here we had 1 zinc, but on the reactant side we had only 1 chlorine in the hydrochloric acid. In order to increase, we are writing it's a state number 2. Means 2 moles of hydrochloric acid we are going to use here to react with 1 mole of zinc. So hydrochloric acid reacts with zinc granules. To form or to release hydrogen gas. This is the product that is going to be formed. Means around the zinc granules we will find little air bubbles type. Means these air bubbles are nothing but the hydrogen gas that is released. This hydrogen gas will try to escape through the glass tube that is arranged. Now most of the students will have a doubt. Sir, how can we confirm that is the gas hydrogen gas? In order to confirm that is the hydrogen gas, we had one activity. You bring a burning matchstick near the mouth of the test tube. When we bring a burning matchstick near the mouth of the test tube or the glass tube, the burning matchstick will blow off with a pop sound. So very important question. How do you confirm hydrogen gas? When a burning matchstick is brought near the mouth of test tube, the burning matchstick blows off with pop sound. When it is brought near the mouth of the glass tube. In this activity, what have we learned is hydrochloric acid when react with zinc, that is forming zinc chloride. Okay. Along with that, it is releasing hydrogen gas. Means during a chemical change or a reaction, reaction, some products, gaseous products like hydrogen gas also may be released. When you want to observe some other change, you can just touch this conical flask. You will feel yourself, that is your hand is getting a little warm, because the reactants are releasing heat towards outside, because the reaction is becoming an highly exothermic reactions. So let us conclude that when zinc is reacting with HCl, it is releasing hydrogen gas, forming zinc chloride, and it is also an exothermic reaction. Now we are bringing the final conclusions for all the three activities that we had learned, that is activity 1.1, activity 1.2 and the activity 1.3. In the activity 1.1, what did we conclude? We had observed during that chemical reaction that this is in the chemical change, there is a change in state. There is a change in state. Means magnesium ribbon was burnt up to give powdered magnesium oxide. Magnesium oxide, that is in the powdered state. That there is a change in state. In the activity 1.2, we had observed lead iodide is formed, that is having an yellow color. So we may observe that there may be also change in color. There is also change in color. In the activity 1.3, we have observed some hydrogen gas was released when the zinc granules are reacted with hydrochloric acid. So we can say evolution of gas. And we can also feel some hot when we have touched the conical flask in the activity 1.3, that is change in temperature. Change in temperature. So what we can conclude is any of these observations, any one of these observations can be observed during